kids, Miss Kulkarni here. In this video, we are going to discuss a new analytical technique, mass spectrometry. So let's begin and find out how this technique can be useful in determining the structure of organic compounds. But before that, let's find out what are the principles behind that and what are some important things to remember about a mass spectrometer. First of all, mass spectrum is like a graph, and the x-axis for that graph is m by z. M by z means it is mass to charge ratio. Z stands for the charge. And then we record the signals. So the signal which we get is the y-axis. And depending upon the intensity of signal, the peaks will be at different level. Now, you will see one of the tallest peak. That tallest peak is referred to as a base peak, for which we consider the height is 100%. And all the other peaks we list as the percentage based upon that peak. There is also one thing to remember. The parent ion or the molecule will have some molar mass. And when we add up all that molar mass, that mass will give a peak. So here is an example of a mass spectrum. And the compound which is given to us is 2,4-dimethyl pentane. Just to understand the structure properly, if you write down all carbons and hydrogen, the structure will be like this. And when we add all carbons and hydrogen, the molecular formula for that compound is C7H16. So, when we try to find out the molar mass for compound, it's 7 times 12 plus 16 times 1, multiplying the number of atoms by the molar mass of the atom. And when we add that, the answer which we get is 100. That 100 is called as the molar ion M plus peak. And here it is, the molar ion peak M plus. That is one of the proof that okay, we have that compound probably. But then there are remaining fragments which also provide some more information. Imagine as if you're holding a pair of scissors in the hand and you are able to cut off these bonds anywhere you want. And what you get is the fragment ions there. So let's say maybe if I use those pair of scissors and if I end up cutting off that CH3 group, that is gone. The remaining part which you have will be the molar ion minus the mass of methyl group. And how much is the mass of methyl group? It's 1 carbon and 3 hydrogen. So it's 12 plus 3, which is 15. So your M is 100 and M minus 15, which is methyl group, that will give us 85. It's another proof that we have an alkane or a structure from which there is a methyl group at the end. Now let's see if we take those pair of scissors and chop this molecule right across over here. We're going to get a fragment which is on the left side, this part, and we are also going to get a fragment on the right hand side. If you calculate the molar mass for the left hand side structure which we got over here, that mass comes out to be 43. And if you want to get the total mass of the structure on the right side, that will be 100 minus 43, or it actually calculate the mass, that's going to give you same answer. It will be 57. So here's the deal. We're going to get two different fragments, 43 and 57. Do we have both those products? Yes. That's again an indication that we got the exact molecular structure. So mass spectrum is quite powerful technique by which you can conclude if you have those groups in particular order. Let's look at one more mass spec. This is a simple molecule CH3OH methyl alcohol. And what is the molar mass for methyl alcohol? It's calculated here. That is 32. If you add up this, it's CH4 and O. So the molar mass for carbon 12, plus for 4 hydrogen it is 4, and plus for 1 oxygen it is 16. When you add that, you end up getting 32 as the molar mass. That M by Z 32 is shown over here. That's a proof that we probably have the right compound. What are the other things which are going to prove that we got methyl alcohol? There is a peak 31. What that peak stands for? If you remove that hydrogen from that, it will be M minus H. And that corresponds to M minus 1, which is 31. How about if we have this molecule and we decide to cut it off, chop it off right across over here? In that case, we are going to get methyl group and OH group. What is the exact molar mass for methyl group? It's 1 carbon and 3 hydrogen, so that corresponds to 15. And whatever is remaining, OH, is going to be molar mass, which is 32 minus 15. That will be 17. So do we have any of these peaks? When you look carefully, you see that 15 is shown up here. That means that corresponds to a group CH3. There is a small tiny peak at 17 present over here. Also, there is a peak at 29, which is removal of these 3 hydrogen. So kind of we'll have a structure CHO. Alright, let's discuss how to identify if we have an alkane or alkene. What type of fragmentation patterns we are going to see. The mass spectrum will correspond to the fragment which we have there. So if you have a methyl group CH3, we should have a peak at 15. Let's add one more CH2. So if we get CH3CH2, that's ethyl group, we should have a peak at 29. Then we add it to that one more CH2 group, and what you get is 43, and so on. So all these peaks correspond to removal of extra CH2 group. The stability, of course, the ions is also important. If the ions are stable, then we see the ions in abundance. We see the larger peak over there. Also, just for your information, if you have a tertiary alkyl group, that will be more stable than a secondary and then a primary group. Let's actually take an example with some alkane. So this is 2-methylpentane, a branched alkane. And we have to make sure that the mass spectrum is in accordance with the structure. The molecular formula which we get for entire molecule is 86. So that is the molecular ion. Pair of scissors in our hand, and we're going to start chopping one by one. What if I cut it off over here? That will be removing that methyl group, which is 15. And the remaining structure which you got here will be M minus 15. That's what we are getting by the peak at 71. What if we decide to chop it at some other place? So the next cutting will be, suppose, over here. We end up having a group which is an ethyl group, CH2CH3, and we also have a remaining group over here. So what is the total mass of CH2CH3? This will be 29. And if this is 29, what is the remaining part? It will be the molar mass 86 minus 29. That is M minus 29, which is equal to 57. So that concludes again the structure which we have for this particular compound, methyl propane. Moving on, suppose if we decide to cut it right across over here. What we got here now is a propyl group with 3 carbon atom. And what is the mass of that propyl group? That is 43. And with that being 43, the remaining structure which we got will be the molar mass 86 minus the fragment which you are removing. The total when we subtract comes 43. So in this case, both the fragments are equal to 43. See what happens? There is the peak 43. It corresponds to 43 itself as one fragment, and 86 minus 43 as the second fragment. Since there are both the fragments with same mass, that becomes a base peak with almost 100% percentage. So do you think the mass peak data is conclusive enough to say we got the right compound, 2-methylpentane? Of course, it looks like we have the right compound. Let's take one more example. This time we got chlorine. And just want to remind, chlorine has isotopes. And the two isotopes could be Cl35 or it is Cl37. That means the mass of chlorine could be either one of those. So if we have this compound with chlorine 37, the molar mass which you're going to get is going to be 80. And if you have this chlorine as 35, then we are going to have the molar mass as 78. There is also one more fragment possible in this molecule. This chlorine can actually come off. And if chlorine comes up, the peak which you're going to get is the molar ion peak minus the chlorine peak. If your molar ion was 80 and chlorine was 37, it will be 80 minus 37, giving you 43. If the molar ion was 78, that minus 35 will give us 43. So either way, whichever isotope of chlorine you got, M minus Cl is going to be still a 43 peak. So that's a solid base peak, which is almost 100%. This actually confirms that we have chlorine in this molecule. Let's talk about one more example. This is an alcohol. So alcohol have OH group as you saw. The molar mass for alcohol should be over here, but you don't see a peak there. The reason is M plus may not be visible if you have an alcohol. But you will always see a peak which is M minus 18. That 18 stands for water molecule. And right here, we got a peak M minus 18 that corresponds to 70. And then there is a possibility of also losing this CH3 group. So this corresponds for M minus 18 for water and minus 15 for methyl group, and the peak corresponds to 15, and that looks like a base peak. So what do you think? Does this conclude our molecule structure? Yes, it does. So mass spectroscopy is really a powerful technique in determining the structure of organic molecules. Okay, I hope you guys enjoyed the video. I'll see you again in next video. Until then, bye bye.